Good afternoon. Good afternoon. Hope all is well and everyone's doing all right. So, giving everybody a chance to get in and then we'll get started. All right. So, last class we knocked out 5-1 and 5-2. Yep, no outcomes are common. Yep, 5-1, 5-2. So we'll look at 5-3 and 5-4 today. Make sure it is a 5-4. It might just be 5-3. Yep, 5-3, 5-4. And that'll be it for chapter 5. And then any questions or anything anybody have, I can most definitely knock them out before we close out today. So 5-3, associations and categorical variables. And so in 5-2, we had a chart. So that's the chart we will be using as far as getting our numbers. So we're getting into conditional probabilities, probabilities of an event that are affected because another event has already occurred. It's considered conditional. So here's the symbolism, the probability of A, and it's not like a slash, more like a line, it's more of a straight line, and then AB, so it's AB. So it's the probability that event A occurs given that B has already occurred. So that line represents given that, so A given that B has already occurred. All right, scrolling up. So to calculate the probability, the conditional probability, we have the probability of A given that B has occurred, find the probability of A and B, place it over the probability of B. Or if you have the number of A and B, place the number of outcomes in B. So the order does matter. You know, whatever numbers or whatever event is right here second is what goes down bottom. So the top is always going to be the same. A and B or B and A will still be the same, but it's the bottom number that will be dictated by the position of this event right here. Oh, somebody said something in chat. Okay, not a problem. Not a problem. Thanks for letting me know. All right, can I scroll up? So example, suppose a person is chosen randomly from the chart. What is the probability a person has less than a high school degree, is married? So the problem, well, I won't say no more, I'll let you write it down. Then we'll get into it. All right. So we want to know the probability a person has less than a high school degree is married. So in other words, married given that less than high school degree. That's the notation right here. So the person has less high school degree was already established is married. So probability that someone is married given that they have less than a high school degree. So we're going to go to the chart and look for the number of people that are married and has less than a high school degree. And then this one being right here means that we're looking for less than a high school degree, the number of people that have less than a high school degree down bottom. So if I go to the chart, and probably the last time I go to the chart since it's all the way up here. No, we'll see. Sorry about that, I had a sneeze. So we're looking at less than high school degree is married, that's 70, and less than high school degree is 125. All right. So there we go, 70 over 125. Less than high school degree, number of people that has less than a high school degree and married, and then over the total number of people that have less than a high school degree, and they end up being 0.56. All right. Before we go any further, questions on what we did there, make sure we're okay.
Can you say again, what does N stand for?
No, the number of.
Number of. Okay.
Yep, I wrote it right here. Number of, and P stands for probability of. All right. All right, so I also told you or showed you. So here we said the probability of, or you can use the number of. So either way, you'll get the same answer. So I was just showing you how it worked here. If we were doing the probability of people married and I'll have a less than high school degree, and then the probability of people that have less than a high school degree, you take that 70 and put it over 665. That was the total number of people altogether. And then take the 125 and put it over 665. And so, and I'm not saying you have to do both of them. I'm just showing you the work behind it. So if you had to do the probability, and when it comes to dividing fractions, you have to multiply by the reciprocal. So that will flip this fraction. 665 will cancel, leaving you with 70 over 125 again. So just showing you that it works both ways. And this is something you could just throw in the calculator. So I'm not even asking you to make sure you know how to do fractional work. I'm just showing it to you. If you were to throw this in the calculator, you'll still get the 0.56. So once again, it's just showing you, how that would work. All right, any questions? You want to scroll up? So they label, remember we had a few rules. We had like rule 1, 2, 3, 4. So this is actually rule 5, probability, conditional rule for the probability. And then also you can manipulate it and multiply the probability of B to both sides. And so both of these are the same rule, just manipulated a little bit. All right, scrolling up. So everybody got the top. All right. So dependent events versus independent events. So dependent events, events that are associated. So, or in other words, events that have conditional probability that change depend on the different conditions. Independent events are not associated, and the conditions of one event does not affect the probability of another. Then we have a general statement: if events A and B are independent, then the condition, or the probability of A given that B has occurred is just the probability of A, because B, doesn't affect A. So it's just the probability of A. All right. All right, so let's look at this next example. Suppose we have 52 cards, standard 52 card deck, all the events. The card is a diamond. Let me erase this. The card is a diamond. The card is red, independent. If you find out another player holds a red card, do you want to know if it's a diamond? I'm trying to see what kind of note I wrote myself. I wrote check right here. So we have if you go there, all the events. The card is the diamond and the card is red, independent. Okay, I don't know what I did there. So we'll see. Maybe it'll come up as I talk about it. I don't know if I read this statement. So basically, if you find out another player holds a red card, do you want to know if he has a diamond? All right. So the basis in what we're doing here, it goes back to the events being independent versus not being independent. If they are independent, then the probability is going to be the same. You know, the conditional probability and the probability without the condition will be the same. Well, if the probability doesn't change, then that, you know, doesn't have any bearing on whether you know whether it's a red card or a diamond or not. But if they're dependent, then the probability will change, and then that will let you know if you want to know whether he has a red card or not, if it even matters if you have a red card or not. All right. So the easier one to find is the probability of getting a diamond. Because we have two events here: the fact that the card is a diamond, and then the fact that the card is red. So first thing, like I said, the easiest thing to find is the fact that the card is a diamond. What's the probability of getting a diamond? That's 13 out of 52 because there are 13 diamonds in the 52 card deck. And then that reduces down to 1/4. So once again, we'll check the next probability. If it doesn't matter, then it'll end up being 1/4. And if they're independent, it'll end up being 1/4. That means the probabilities doesn't matter. And it doesn't, you know, you wouldn't need to know if the card was red. So now we're looking at the probability that the card is a diamond, given that you know it's red. All right. So if we're trying to find the conditional probability here, the fact that the card is a diamond, given that it's red, first of all, you need the probability of all diamonds that are red. And of course, that's 13. If it's diamond and red, that's 13 over 52. Then the probability that a card is red, that's 26 over 52. Remember, that's going to be, there are 26 red cards. I wrote it right here. Yep. There are 26 red cards. So it's 26 over 52. You know, you have diamonds and hearts, 13 apiece. So 26 red cards. So now if you were to simplify, that'll be 13 over 26, which would just be a half. So before we come to our conclusion, are we okay with the calculation? All right. So since the probabilities are not equal, then the events are not independent. This means that knowing that someone has a red card is useful in determining if a person has a diamond. All right. Problems before we go to the next one? All right. So next one, the card is face down. This time you want to know if your opponent has an ace. You discover he already has a diamond. Is this helpful? All right, so just like before, we're trying to determine if the events are independent. So we're looking at having an ace. There are 4 aces in the deck. So 4 out of 52 is the probability of getting an ace. And so that reduces down to 1 out of 13. So we want to know the probability of getting an ace, given that you know the person has a diamond. So we're right here, the probability of an ace and a diamond over the probability of a diamond. Remember, this one always go down bottom. So there's only one ace. That's a diamond. We have ace of diamonds. And then there are 13 diamonds in the deck. So reduce that, and that gives us 1 over 13. Any questions with the calculation? So since the probabilities are the same, the events are independent. This means that knowing someone has a diamond does not help you determine if they now have an ace. All right. Any questions? Any questions? All right. So here the multiplication rule 5C, which is another variation of 5A and B. If A and B are independent, excuse me, A and B are independent, so that's key here. Then if you want to know the probability of A and B occurring, you just multiply those 2 probabilities together. Gonna scroll up. Anybody hold on to that top blue? All right. Suppose that 51% of all babies born in the US are boys. What is the probability of a family planning on having 2 children will have 2 boys? All right. So we want to know the probability of having two boys. These events are independent. So having a boy the first time does not affect you having a boy the second time, or vice versa, or whatever the case may be. So they are independent. So the probability of getting a boy is 51%, according to what we have right here. So if you're talking about the probability of getting a boy first and a boy second, I'm going to take those two probabilities and multiply them together. So 0.51 times 0.51 is 0.2601. All right. Any questions? Questions? All right. So then it says, what about a boy first and then a girl second? So according to this, boy, girl. If it's 51% to get a boy, then minus that 51%, 0.51 from one, that'd be 0.49 to get a girl. And so then you multiply those two probabilities together. 0.51 times 0.49 is 0.2499. All right, questions? We'll go to the next one. Everybody good? All right, so toss a fair coin 3 times. A fair coin is equally likely to land up either side when tossed. What is the probability that all 3 tosses are tails? All right, so these events are independent. Tossing the coin and landing tails has nothing to do with tossing the coin the next time and landing heads or tails or anything like that. So these events are independent. The probability of landing tails is 1/2, or 1 out of 2 chance. So in other words, 50%. This is just, walking through that where it came from. Number of options for our sample space is 2. Tails is just one event, one option in your event. So it's 1/2. I believe we talked about that before. All right. So since they're independent, we just multiply them together, 1/2 times 1/2 times 1/2. That'll give us 1/8. And that is the probability. All right, next one, what about 2 heads and 1 tail? So if tails is 1 out of 2, that means heads has to be 1 out of 2 as well. 50% chance, 50 plus 50 is 1, 100 or 0.1 or 1. We'd be looking at 0.5. So the probability in the calculation doesn't change. It's still 1/2 times 1/2 times 1/2. Just that this one's pertaining to heads, this pertaining to heads, and this one pertaining to tails. But still the calculation of 1/2 times itself 3 times, which give you 1/8. All right. Any problems with that before we look at 5-4? All right, so 5-4, finding empirical and simulated probabilities. Empirical probabilities are probabilities based on carrying out real life random actions and observing the relative frequency that an event of interest happens. Finding empirical probabilities can be slow and laborious, and for this reason, it is often useful to perform a simulation that can be carried out rapidly. Mhm. Simulations can also be helpful when a situation is too complex to find a theoretical probability. Of course, if I scroll up too far, let me know. All right, so here, start right here. For example, so we wish to know the probability of getting exactly 2 heads if we flip a coin 3 times. To find an empirical probability of this event, we flipped a real coin 3 times and noted whether or not there were exactly 2 heads. We repeated this for 5 trials, and then we have some results. So give you a chance to write that down, and then we'll scroll up to the results. All right, scrolling up. So here's the table. We have 5 trials. In other words, flip the coin 3 times. Flip the coin 3 times, 5 different times. And this is what occurred. And we're looking for exactly 2 heads. We had for the first trial, heads, tails, heads. Second trial, heads, heads, tails. Third, tails, heads, heads. Fourth, tails, heads, tails. And then fifth, heads, heads, heads. So what is the empirical probability of getting exactly 2 heads and 3 flips based on this data? So notice that 2 heads is actually 2 heads happened twice. I mean 3 times, excuse me. So it would be 3 out of 6. I mean 3 out of 5. That's all my numbers up. 3 out of 5, which would be 60%. And that's just based on this data right here. All right, scrolling up. All right. So then the questions that come up, and these are just notes that they, you know, how in the way your book is set up, in the beginning of the chapter, there's a lot of writing just talking about what's going on. And then at the end of the chapter, they do the same. So it's the end of the chapter close out. So why is this important? Why can't we rely on this probability? Why can't 5 trials be enough to determine a dependable probability? So we're about to get into those whys in a second. Just give me a chance to finish writing down. All right, let me scan, do something real quick. Okay. All right. So let me see, did I write them down? Okay. Okay, so basically, when we look at these questions, we're about to go into the law of large numbers. It's going to tell us why We can't rely on this because it's not enough of a sample size. This is important to help give us a estimate of what's going on, an idea of what's happening here. And but those last two questions basically lean on the law of large numbers. And it lets us know that those numbers, 5 trials is not enough trials to be able to make an educated decision on what's going on in your probabilities. So the law of large numbers is a theorem that tells us that if our simulation is designed correctly, then more trials, the more trials we do, the closer we can expect our empirical probability to come to the true probability, which is the theoretical probability. So 5 trials is not enough to get to what they call the true probability, which is the theoretical probability. Theoretical is based on, and we'll see in a second, I'll just give you a chance to write it down, but theoretical is based on infinitely many amount of trials being ran. That's why it's considered theoretical. All right. And so as we approach infinitely many trials, the true probability and the empirical probability approach the same value. All right, scrolling up some. All right, so an example of both of these, comparing the two, flipping a coin and landing tails. If I were to flip a coin 10 times, the result could be that 7 tails, it landed 7 times tails up and then 3 times heads up, which would make the empirical probability of landing tails is 7 out of 10, which is 70%. But the true probability we've calculated already is 50%, 1 out of 2. We got a 1 out of 2 chance of getting tails versus heads. Right down with the black. So law of large numbers is basically saying that if the coin is flipped more times, then the probability will come closer to the true probability, which is 50%. All right, everybody good? So simulations, which is what you would need to help you do something infinitely amount of times. Simulations are normally done by some type of program or application or technology. And then I believe this is the last thing that they hit on. What if my simulation does not give the theoretical value I expect? And we have 2 possible explanations. All right. It is possible that you could have calculated a theoretical value incorrectly. And then the second option is that your empirical probability is just varying, and that just means you need to do more trials. So what I mean by that is that, let's say you're talking about flipping a coin, you could go on a streak of hitting all heads for a little while. It could do the same thing for tails, but eventually, infinitely, it will actually even out to give you that 50%. So just need to do more trials in order to get it there. Questions on that? That's it for 5.4, which means we're done with chapter 5. Questions on anything I've said today? I know I got somebody who mentioned asking a question. I'm assuming about something discussed previous, but as far as what we talked about today, any questions? Everybody good? Everybody straight? Okay. So as far as what you guys are here responsible for to this point, you got chapters 1, 2, 3, 4, and 5 homework, and then we have 2 tests out there. Test 1 is chapters 1 and 2. Test 2 is 3 and 4. 5 and 6 would be a third test that probably will be proctored. I'm gonna look and map this thing out and see. So I'll solidify that on Monday, or whether we're gonna do that or not. But yeah, so that's where we are. So before we close out, go into the weekend, we'll close out this session because, like I said, I most definitely need to address the question: is everybody good? Any questions on what we're doing up to this point? Everybody good? Everybody straight? Okay. So I know I have a question on the floor, but if you don't want to stay for your classmates' question, you are free to go. Have a great weekend. Be safe, and I will see you on Monday. Gotta get you. Okay. Ms. Finch, are you talking about in my office hours, or you just talking about you gonna set up a time? Let's see. Okay, yeah, because you said after hours. I was like, I was like, after hours, what that mean? It's all good. So yeah, so I'll talk to you later. That's not a problem at all. All right, so powers. What you got for me?
Okay, so I understand the concept of doing the regression line. I don't have any problems with the follow the formula, etc. But say tests in my math lab, if you go to the test review, say question 46.
All right, let me get there. Give me a second. All right, this is 155. You said test review, what number again?
Question 46.
Oh, 46. I got that many questions up there.
Yep.
Well, I know the test shouldn't. Let me take the test. Let me check the test. The test shouldn't have that many questions up there. Hold on. Yeah, the test only has 26 questions. All right. All right, so 46. All right, so this is what we're looking at right here.
Okay. So I know how to find the regression line, like the knowledge of how to do it, how to find the slope, how to find the intercept. Like I get that.
Mhm.
My problem is I'm really struggling with the actual calculations because I'm assuming because of the difficulty I have with transferring stuff from the data table
Mm.
to an online calculator. I'm assuming that I transpose numbers or I miss a number or so I'm like, there has got to be some little thing that I can click that it does that calculation for me without me like losing my mind.
Right.
Because I'm spending like an hour on a problem and still not getting the right answer.
All right, I'm looking right now.
And I'm like writing the whole data sheet down, you know, on a separate paper and still get like, I'm like, this, I know how to do the problem.
Mm-hmm.
It's not that I don't understand how to do it. It's the
Yeah,
number, the answer's not right, which
Mm.
you could say would mean I don't know how to do the problem, but
No, you're fine. Trust me, I get it.
like
I'm
this
trying to
one has like
see.
29 pieces of data.
Mm-hmm.
Well, more than that. So
Trying to see if I can figure out a way to do it. I know there's a way.
yeah, so I'm like, there's got to be a way that I can like, but like I've tried like opening it in Excel, but you can't copy and paste from Excel to the online calculator that I found. And so I end up having to like click back and forth between the screens and I'm just like, you can't be expecting me to keep track of 58 different numbers in this data
Well,
table.
of course we would. Okay, here we
And
go. Let me see. I may have it. Let me see slope. Let me see if these work first though. Because you can't see the screen that I have up for StatCrunch, right? Okay.
no.
Okay. So I have to do it again, but let me see if this works first. All right. So I need 2 decimal places. So it's 4.02. And then slope. Let's say estimate though. Okay. All right. So let's do this, close it out. All right. So we open up this and hit this button right here. And we open in StatCrunch. I don't know if you remember the first day of class I mentioned that StatCrunch was their version of Excel.
Yeah, I have
So
opened it. I couldn't figure out how to work it. So.
yeah, no problem, no problem. So it was only for anybody who wanted to, try to mess with it. I wasn't going to make it mandatory that anybody did. But what we can do is go to Stat, go to Regression, Simple Linear. So make sure we're good. So we're going to, because there's another place that like here it says regression too. So I'll make sure we're good on where we're going. Go to Stat first, then regression, and just hit simple linear. All right. Can you see this chart right here where it says X variable, Y variable?
Okay. Yeah.
Oh, you can see it because sometimes when I open up different windows, then I have to go switch it again. So I just want to make sure you can see it.
Yeah.
So hit X variable is father, because that's our first.
Okay.
And then Y variable mother. And then hit compute. And these right here. See how it says intercept 4.02, slope 0.546. And that's it.
Okay. Now, do I? Okay, so I don't need to actually do. Okay, because that's much simpler because I was
Mhm.
doing the whole like the formula you had us in class where slope, B equals R times
Mhm. Oh,
SY
yeah.
over
Now
SX.
you're right. If you have a data set, I most definitely wouldn't do that.
Well then
Uh,
okay. Because I
because
was like,
see,
this is just, I'm like, I can't like,
right now, I would do that formula if you had, let's say, if it's given to you like this. Let me see if I can find one. Might be going the wrong
because
way.
I've been doing typing all 29 numbers into a calculator, an
Right.
online calculator, and then adding all 29 numbers to find the mean.
Right. Oh no. Yeah. If
Okay.
I had a data set now, type them into an online calculator is not the worst thing in the world. But when you do have 29, like you said, that's when it becomes a little cumbersome.
Yeah,
Um,
because I'm like, I know how to follow the
mhm.
formulas you gave us,
Right.
but there's just so many numbers that I'm missing, or
Right.
something's
Right.
going wrong with the flipping from screen to screen so that I'm not getting the right answer, but it's not
Mhm.
that I don't know how to look for
Right.
the answer.
And yeah, most definitely, I get it. That's why I was trying to make sure I found a way to help you out there.
Okay, great.
But yeah, that'll do it. Because like before, because I normally don't play with it, and I only go to it when somebody asks about it. So then I got to go figure it out. But yeah, so that'll do it for you right there.
So go to stats. I'm just going to do it on my screen.
Hmm.
Stats, regression, simple linear,
Hmm.
and then pick which variable,
Hmm.
and then just click compute. Don't fill out the other stuff.
Right. Well, I didn't have to. So
Okay.
yeah. As a matter of fact, let me see.
And so that's going to give me all that stuff.
Mm-hmm. Let's see.
So
Because
basically it solves the problem for me.
mm-hmm.
Okay, because I'm like trying to like memorize the formulas so that when we have the test, I can like,
Well, if you or even on tests, I was gonna, let you use your notes and stuff. I wouldn't put you in a position where whatever you use for your homework, you'll be able to use for your test.
okay. So like say for example, when we go to the test, will we be able to access stat
Mm-hmm.
crunch and
Yep.
stuff? Okay.
Yep. Um, I'm not going to use a lockdown browser or anything like that, so you should be able to.
Okay.
Mhm.
Okay, well, this is much, okay. So since it does all this calculating, I don't need to actually know what Y bar or X bar are because
No,
those
unless
aren't,
you see a problem that asks you for it, then no.
okay.
Yeah. Yeah, because yeah, these problems will be the same problems you'll see on your test.
Is there a way in StatCrunch, just in case, like it asks for the mean or of
Uh,
a large data set that you can
should
like,
be. Yep, all of that does it. You just, I just have to play with it.
okay, because I
Yep. Let me get.
tried doing that just so I could make some things like so I could figure out X bar and Y bar so
Mhm.
I could do these calculations and I couldn't figure it out. So I didn't know if you knew how in StatCrunch to like
Let's
add
see.
those columns and stuff.
Right. So Stack Crunch. Nope. I didn't know
Oh
the
my word, I'm gonna be
data.
done with my homework in like 30 minutes rather than like I've spent 3 hours plus today trying to like on like 3 problems and kept getting
Right.
it wrong. I'm just like, I know that this cannot be normal. Like, there's no way anybody has a career and goes to work every day and does this.
Right,
And
right,
spends
right.
like society would grind to a halt if statisticians took this long to like figure out a problem.
Why is this not selecting another one? Trying to see column. Nope, don't want to do that. Two-sided p-value. Nope. Yeah. You must select at least two values. Select columns.
Just a minute.
Okay, there you go. All right, so stats, summary stats, the correlation. Okay, there it goes. Oh, you can't see my stuff. Okay, hold on. Okay, so if you go to stats, there's the stats, summary stats. So you can do correlation right here too. You know, out of 4 point, no. Yeah, it was 4.1, either 4.1 or 4.2. For columns, if you highlight both, and here, and you see right here, it says mean, variance, standard deviation. So there it goes right there.
Okay.
I even give you your quartiles. Q1, Q3,
What?
range, median, yeah.
What? Wow. Okay. All right. Go back and show me again what I need to click when I open up StatCrunch.
Go back to stat,
Uh-huh.
summary stat,
Uh-huh.
and columns.
Okay.
And then you highlight both, you know, click and drag your mouse.
Okay.
And just hit compute.
Well, I just gained back like 20 hours of my week. So, okay. All right. Let me try doing both of these again on my computer so I can make sure that I can hopefully do
and then
this.
correlation is done the same way. Yep. Just highlight both, hit compute.
And do this one more time. Okay, well, there we go.
All right.
Thank you. That is beyond helpful.
Not a problem.
Okay. All right.
All right.
Okay, sounds great. Thank you. I really
Not a
appreciate
problem.
it.
Glad I
very
could help.
much. Okay,
All right.
thanks.
You have a good one.
You too. Bye.
Bye.
Oh, quick question. Do
Yes.
you think you usually will post lectures by like Friday or Saturday for that week so we can work on like rewatch or
Yeah, so basically talking about today's lecture.
yeah.
Yeah. I'm gonna try to do
like
it today. I'm gonna try to do it today.
Okay, just yeah, I just was wondering if Monday and Wednesday's lectures can get posted by like Friday afternoon, evening, that's helpful so I can work through the
Yeah,
weekend.
that's normally the goal. I've just
Okay.
been lately. It's just been because I'm moving and all the stuff
Oh,
like that. It's
I
been
hear
kind of
you.
crazy.
I hear you.
But yeah, I'll try to. Like I said, I'll try to get that in tonight since I have a little bit of free time this evening.
Okay, sounds good. Thank you.
All
Appreciate
right,
it.
no problem. Take care.
You too. Bye.
All right. Anybody else before I close out? Anybody? All right. Well, you guys have a great weekend. Be safe, and I will see you next class.